Hello everybody and welcome to Let's Prototype, a new series that I am launching where we go through various processes to learn how to make. And so we'll look at different manufacturing processes and different circuit boards and different programming languages. We'll look at 3D printing, we'll look at laser cutting, we'll look at all these different things. We'll look at how to make circuit boards, and we'll learn together. I'll share what I know. It'll be a fun journey. So if you haven't already, quick little plug. Toss me a follow down below. Subscribe here on YouTube and also on Twitch, where I do these kind of things live. And keeps me going, keeps me motivated, and lets me know that you like what I'm doing. So without further ado, let's jump in. So the overview for this video is that first we will talk about future videos, and I'd like to gather some input from you, and then we'll jump into the goals of this tutorial, followed by the steps that we'll take, and then finally we'll jump right in and we'll actually start making. So on this adventure, I would like to know what you want to see. I have my own personal interests, I have my own personal experiences, and then there's also what you want to learn and what you want to see. And so this first demo is just going to be a quick pass through all the different things that make up a project, but we'd like to start to explore other ways of tackling challenges and building prototypes. And so there's different circuit boards, there's different programming languages, there's different manufacturing methods, there's lots of different things. There's sensors, and there's connecting to phone and to Twitter and all these other features. And so this right here, this is what you see, is just a small sliver of all of the possibilities of things that we could create together in this Let's Prototype series. I want to hear from you. What do you want to see? Please comment down below. So I have this goal of taking an idea from a simple circuit to a completed piece of hardware to use. And I think that for the most part, this will actually be kind of the definition of what Let's Prototype is. We'll take some idea, we'll gather a collection of tools, we'll put them together, and output will be some prototype, not necessarily always purely hardware, might also be digital in terms of programming and web connectivity and things like that as well. But that will kind of be the repeating theme here, is that we want to start out with an idea and see as quickly as possible we can convert it into a prototype, and that we can get that prototype out into the world so that we can start to collect feedback, we can iterate, and we can improve on our ideas. The goals for today will be to create a nightlight circuit with the Arduino. And a nightlight is really just when there's low light in the room, like at night, a light will turn on, and then during the day, it'll turn off. And so we'll start by making that with Arduino, and we'll put it on a breadboard. And once we get it working on a breadboard, we'll move it over to a completed kind of soldered together circuit board. And then we will take that, we'll move that into CAD with Fusion 360, and we will build a little housing for our nightlight. We'll print the housing, and at this point we will call this project done. But typically at this point what you would do is you'd repeat steps 2 to 5 until you have something that is worthwhile and ready to take out in the world and test. And also while you're testing, you'd probably repeat steps 2 to 5 as well. So those are the goals for today, and now let's jump over and get to making. Or should I say prototyping? For this particular project, I wanted to start with the design of the circuit. And I think every project's different, and kind of the steps in which you take to complete a project are different. But for this one, particularly, I didn't quite know the arrangement of how all the pieces would fit together in the circuit, and so I thought it was best to start with the circuit. So got an Arduino Pro Micro, and happened that one of the pins were missing, so just real quick adding one of those on, and then I'm going to go through and solder those on before continuing on to building the rest of the components. Soldering is not the most important skill to have. You can get away with doing a lot of these things without soldering. You can bring prototypes to market without soldering. The breadboard that you see here, which is the white block where the circuit board plugs into, actually has a sticky adhesive back. And so if things rest nicely into the breadboard, you can actually just get away with skipping the whole soldering process. But sometimes you'll find that you need to make changes, or you'll order parts like I did here, and it arrived and it needed to be soldered. And so soldering is a good skill to have. You can find many tutorials to do it. It's not that hard to pick up. Highly recommend learning soldering. Cool. So we have our Arduino plugged into the computer, and it's turned on. And so now we're going to go ahead and start wiring up our schematic. So first we're going to start out with some LEDs, and as a little aside here, I like to kind of test things as I go. So you'll see me right here testing that each of the LEDs works, and I like to know that everything works before I start putting it all together, because debugging is always kind of a nuisance. So kind of like this, I'll try and plug in little facts as we go along the way to help you in your prototyping journey, because prototyping should be easy. You should be able to do what you want and have fun with it, and not get stuck on figuring out why your LEDs don't work. Oh, because you got a bad LED. So usually what I like to do when I have components that I don't know how to use, I will Google them. And in this case, I'm Googling a resistor. In this case, I'm Googling a photoresistor, and that's kind of where the magic happens. And a photoresistor is capable of measuring the amount of light in the room. And so I'm going through here. I found an example project, and with Arduino, you can find tons of these. And so I'm going through and I'm disconnecting my little circuit that I made for the LEDs, and I'm wiring up this photoresistor. So I like to test things in isolation. So I disconnected my LED circuit, and now I'm just plugging in my photoresistor, and I'm checking and making sure that it works. And I'm grabbing some sample code that I can throw into my Arduino software and upload to the Arduino and then test out. So I like to grab examples. They're a great place to start because someone else has already proven that you can do the thing that you want to do. And I'll go through and kind of start with the example and then strip out the code and things that I don't need. So that's what we'll see me doing here. And then I'll throw in things. Serial.print helps me debug and troubleshoot, so I add those things in. And now I'm just cleaning up the rest of the code so I can focus on exactly what I want to do with this code. And we are ready to test. So go ahead and configure our settings in Arduino, and we are uploading. So back over to the board, we can try out when we cover the sensor, and then we can see our values get read out there. And then that's kind of the foundation where now we have these LEDs that work, and we have this photoresistor that works. And now we need to write some code that connects the two. So again, kind of in isolation, I'll comment out the code for one part of it. I'll write the code for the other part of it, make sure that works, and then slowly start to combine the two things together until both of them work. So here I am writing just a simple kind of proof of concept to make the LEDs work. Just a simple blink, make the LEDs turn on, and then make the LEDs turn off. And so go ahead and write this example code for the Arduino. And I'll upload it, and I'll see that, hey, it works. Awesome. So now it's time to connect the two together. So I'll uncomment out the code that I commented out for the photoresistor, and I will kind of start to modify it so I can combine these two things together so that I can use the photoresistor to control the LEDs. So simple logic, just a little if-else block. If the values are lower than some threshold, we'll turn the light on. If the values are higher, we'll turn the light off. And real quick, I just want to check what those thresholds are. So that's me opening this serial monitor here. And I'll put a little comment in so I know, what I'm dealing with. And we go fast in prototyping. And it's a rush to the end to get a physical, it's to get a completed thing that we can put in front of users and have them test out. And so it's not always perfect, it's not always beautiful, it's not always clean. We go as fast as we can to get a thing that we can then start collecting feedback from. So a little shout out to one of the mentors in my life. Their advice was that you have 6 months to bring something to present it. So if you're working in a startup, not so important. But if you're working in a corporate company, and you spend 6 months sitting on a prototype and you don't have anything to show for it after 6 months, your management starts to question you. So the faster you can get out there and deliver your thing, the better. So now we have everything wired up together and we're checking it out and it looks like it works. And so we will call the breadboarding process done. So next up is the process of moving things to a more permanent home on a circuit board. And personally, I do not enjoy this process. For quick prototypes, it makes sense. If you want to get something assembled and ready to go within hours, this is the way to do it. I would much rather prefer to build a printed circuit board in EagleCAD or KiCad or a similar software, send it off to be manufactured, and then solder the components on to the board that you get back. This process of wiring everything together, of laying out the components, and all this is just full of error. My first adventure into making one of these, if I was experienced, probably would have took me an hour. I think in total it might have taken me 12 hours to assemble. There's a lot going on here, but if you got the experience, this is the way to go. And if you don't have the time, this is the way to go. So basically what I'm doing is I'm taking component by component and I'm laying them out into this circuit board that I have here, which I ordered off of SparkFun, and it's kind of like a breakaway circuit board, so you only use as much circuit board as you need. So at the end, you'll actually see me snap the edges off, and I'll have a nice little square leftover that has only the circuit board that I need. And so I'm basically moving all of my components one at a time over to this board. And it's a long, fun, smelly process. You're breathing in fumes and all that good stuff, and you're probably going to mess things up. Luckily, I managed to get this all together on the first go. And so solder all the components on, and then you'll need to wire them all up and all that. At this point, I like to start taking the circuit that I've designed and taking measurements of it. So I do this generally with pen, paper, and a set of calipers. Calipers are a great tool to getting very precise measurements. So here I'm getting measurements up to the 100th of a millimeter. I generally only go to full millimeters for depending on the project that I'm working on, or half millimeters. And so I'm taking dimensions, widths, heights, depths, distances between components, and things like that. And so what I will do is I will take what I've built here and I will put this into my 3D CAD software. And we'll see that in the next step. And this is always a great way to visualize your model and how it will fit into a case before you actually build the case. So the first step of doing such a thing is always actually just to model the thing that you've built. And then from there, you'll use that as a starting point to build the case that you want to use, or the housing that you'll want to use for your circuit or your design. And I don't always try to get all of the notes down or all of the dimensions down, but I like to get most of them down so that I'm not constantly picking up my calipers, measuring, and writing things down. So I like to do this step all in one. All right, so quick timeout here. I accidentally managed to lose the footage for me converting this drawing you see here into SolidWorks, which you now see here. So hopefully next time I will do this properly, and I apologize for that. So now that I have my circuit board modeled, I will start to model the housing for it. And so I've decided for this, I'm going to do a quick top half and a lower half, and together it'll kind of create a sandwich around the circuit board, and that'll be enough to kind of prove what I would like to do with this prototype. And so here you see me grabbing a lot of numbers in and kind of crunching some numbers. And basically what I'm doing is I'm grabbing numbers that I've written down on paper. So for example, if the circuit was a width of X and a height of Y, I would then add a case around that was X and Y plus 2. So just add a little bit of spacing around the case. And so I use those numbers for reference. And design initial, just kind of crude parts, and then I bring them into an assembly. And an assembly is a place where you can look at each of the parts and kind of put them together. So I'm now starting to make all the parts relative to each other so I can see how they'll eventually come together. So fiddling around, I'm struggling with SolidWorks, but eventually I figure out what I want to do. And so now I have a rough, very, very rough idea of what I want to build. And so now that kind of got things into place, I can start to improve the top and lower half, which at this point are really just very basic looking shapes as you see here. And so what I want to do is I want to start adding first in the bottom half a little shelf on which the circuit board will sit. Sometimes when you get circuit boards manufactured, you can get little holes drilled into them that you can put screws into, but in this case we didn't have that, so I had to think a little bit creatively, and I decided to add a little shelf. And so you can see me resting the circuit board onto that shelf, and so now the bottom half is about where I want it to be. And so now the top half is going to need some work of its own, and so I need to make space for the photoresistor, for the LEDs, for the USB connector to supply power to this whole circuit. And so that's about what I do next. Got some dimensions wrong, so I fiddled for a bit longer than expected, and then got a little bit confused about how I was dimensioning things. So that's my little kind of panic that's going on here. And so we'll let this play out real quickly. This is me, again, getting confused because I did things backwards. And this is why it's just kind of great to have this prototype of, or this model of your actual circuit so that you can reference it and see like, oh, did this actually make sense? And go, oh, no, it didn't. All right, back to the drawing board. I'd actually done the dimensions on the wrong sides, and so I flipped them around, and then things turned out well. And at this point, you can see that now I have a little slot where I can plug a USB connector in. And next up, I want to make some space for the LEDs and the photoresistor. And I had originally thought that I wanted to make some space between the photoresistor and the LEDs because if you think about it, if a night light turns itself off because of the light that it produces, then it's not a good night light. And so ended up didn't need to handle that, but is a consideration that I might make in the future. For now, I went the kind of lazy route and just cut a giant hole in the top half to make room for the LEDs and the photoresistor, which you can see me doing here. I take this little pause and I like this design, but then I go back because I'm thinking about actually I'm manufacturing for 3D printing, and that little overhang that you see there doesn't work well for 3D printing. And so I decided to just go ahead and that kind of L that sticks out there. I went, and then I deleted it because it won't print well. So now at this point, I have an upper and a lower half. They're not actually going to stick together permanently, but I said I didn't really care. I'm just going to tape them together because it's a prototype. It's quick, it's fast, it's sturdy. That's the point of this. Let's prototype. So at this point, we are done with SolidWorks, and we're bringing it over to Cura, where we are getting it ready to 3D print. So we are throwing it down onto this simulated print bed that we see here, checking our settings, and this is a whole other art of learning how to do these settings. So you can go off and find videos related to your printers there, and then bring it over to Octopi, which is software I use to control the 3D printer, and then we are good to go. We're heating up our 3D printer, and we start printing. So here's a lovely little time lapse of our 3D printer in action, going layer by layer. And so the great thing about 3D printing is that you can go from a CAD model to a 3D printed model that you can play around with on your desk in just a matter of hours, minutes, and not weeks, which is what I'm used to back in the years ago when I used to do this kind of stuff. You'd have to wait weeks to get the turnaround on these kind of things. So at this point, we have our top and lower half printed out, and we can start to look at things together. Doesn't come together perfectly, and so we end up using a little bit of tape to put it all together. But that's okay because we really just want to see if it functions, if it works, if we can get some input from people. We can make it pretty in the future. Right now, we want to make it work. Even right there, you'll notice that, oh, the connector doesn't actually work that well, and whoops. So we could reprint, we could remodel, or we could just disassemble and break off pieces of plastic until it works, which is what I ended up doing here because I want to wait for it to print again. So I'm just breaking off a piece on the top, putting it back together. Now we're good, taping it back together. And now we have a basic nightlight. And we are done. So at this point, that's it. We've gone through taking an idea, putting it onto a breadboard, writing some code for it, moving that code and that idea to a more permanent circuit board, and then 3D modeling and 3D printing a housing that goes around that circuit board. And at that point, we can take what we've built, we can take it out into the world, we can test it out. I could probably just plug it in my bedroom and see how it functions as a nightlight. And at that point, you can kind of repeat those steps. You can refine the process. You can write better code. You can improve your CAD model. You can improve your 3D printing process. You might want to reach out to external companies to have them do your manufacturing. And so that's where we can take it from here. And if there are specific next steps that you'd like to learn about, I've gone through a lot of them. I would love to learn about even more of them. Please, please, please comment down below. Let me know where you want me to take this next. If you like what you're seeing, please toss me a subscribe here on YouTube. And also in the links below, you can find a way to my Twitch where I do these kind of things live. Really just trying to do this for you. I love learning, I love building, and then I love giving back and sharing with the world. And so your input will help guide this stream. So please, please, please give me your feedback. And yeah, so that is it for this video, this tutorial. This is kind of the roughest process, the roughest overview of what it would take to take an idea and turn it into something that you can show to somebody else and they can try out. So until next time, this is Let's Prototype. I'm Travis the Maker. Thanks for being with me, and we'll see you next time.